Hello and Happy New Year. Today we're back on the Commodore 128 DCR, where last time we converted it from a French one to an English one, but it left one little niggling problem, which is hopefully what we're going to sort out today.
But first, let's have a recap. Last time I managed to change the French keyboard layout into a US-UK layout by swapping the 32K kernel ROM chip. That didn't fix the French font though, but that was easily solved by changing the 8K character ROM. But I was left with some weird behaviour of the caps lock key. Pushing it not only engaged caps lock, but also continued to swap the font, albeit one which was much closer to the C64 one than the French one. This is particularly obvious on the lowercase I, which changes from a serifed one to a sans serifed one. And this didn't just affect 128 mode, but also 64 mode, which seemed a bit odd and meant I had to keep the caps lock key down to get the correct C64 font. Finally, in the Commodore 128's 80-column mode, at first glance it didn't seem to alter the font, but checking further, the position of the caps lock key at power-up selects the font to be used. This is because the VIC font is copied across to the RAM used by the VDC chip that runs the 80-column mode only at power-up. I can, however, force a re-download of the active font by pushing the caps lock key again and calling the kernel routine dlchar at hex ff62.
Okay, so this didn't seem quite right, and I had some people comment saying that I needed to adjust some jumpers on the motherboard to complete the modification.
Looking at the 128 service manual, the circuit diagram showing the character ROM for the DCR is shown on page 84. If we zoom in, we can see the line from the caps lock key comes in, passes through jumper 7, and then feeds on to a couple of places, including pin 2 of the character ROM. Pin 2 is the address line A12, which selects between the bottom and top 4K on an 8K ROM. I'm not sure about J15 and J16, but they take translated address line TA11 from the MMU, and I'm going to ignore those for now and hope they do nothing important. Looking closer at jumper 7, we can see there's also a signal coming in from the 128/64 line, which states which mode the computer is running in. Right, so what I think should happen is, on a machine with a country-specific font ROM, like mine originally, J7B should be shorted and J7A cut, allowing the caps lock key to act as a country code key and select between the top and bottom halves of the character ROM. However, on a machine with a caps lock key and no country-specific font ROM, J7A should be shorted and J7B cut, allowing the 64-128 line to determine the font based on which mode the computer is in.
Right, so let's get the case off this and then see if we can find that jumper. Okay, so if I put my probe on the 7B jumper terminal, you can see that the voltmeter is reading 5 volts. Now if I push the caps lock key, you can see it drops down to near 0, and if I release it again, it raises up to 5. So it seems that 7B is connected to the caps lock key like the circuit diagram shows. Okay, let's look at jumper 7A. So if I put the probe on 7A, you can see it's reading 4 point something volts, near enough 5, but we're in Commodore 128 mode. So if I type go 64 and jump into Commodore 64 mode, then you can see the voltage drops down to near 0 volts. So that seems to work the same way as the circuit diagram too. Okay, so one last thing. If I change the multimeter over into continuity mode and take the two probes, we can see that the common terminal is not connected to the 7A jumper, but it is connected to the 7B jumper. The layout of this board is a bit confusing because the common part is actually connected to the right hand side of each of these jumpers, and it's the left hand side that's actually connected to the caps lock key and the 64 mode line. So anyway, we can confirm that the jumpers are connected to the caps lock key. Right, so I've got a screwdriver to scrape away the solder and cut one of the jumpers, and I've got a soldering iron to close the other. So let's get to it. Okay, so surgery's complete, and whilst it didn't go quite to plan, the patient is alive and it's successful. So I'll show you with the help of a few diagrams exactly what happened.
So I'd put my multimeter probe on the bottom left-hand corner of J7, and I'd managed to measure continuity between there and the right-hand side J7B, and J7B was shorted just like it looked to be in the circuit diagram. I also managed to confirm that the right-hand side of J7A was connected to there as well. Now the left-hand side of J7A, however, was connected to nothing. So I concluded that there must be two secret traces between the right hand side of J7A and the bottom of J7B that connected to the bottom left hand corner. And the caps lock key went into the right hand side, the 64128 line went into the top left, and the output to the character ROM came from the bottom left. So what I thought I had to do was cut J7B to disconnect the caps lock key from the character ROM output, and then short J7A, which would then connect the 64128 line onto the character ROM. Now if I managed to do this without any problems, then everything would have worked fine, but I actually messed this up, which I'll show you in a moment, and that allowed me to get into a complete muddle because I had completely the wrong idea of what terminals connected to which things on the motherboard. So before I tell you what I did, this is what the board actually looks like. So J7A, the right hand side, is actually touching the right hand side of the sort of triangle terminal. And what really happens is the 64128 line does go into the top left, but the caps lock key goes into the bottom left and the character ROM comes out on the right hand side. Okay, so the first thing I managed to do successfully, which was cut J7B, and I actually did this by heating it with the soldering iron and then using the solder sucker to remove the blob there, and that correctly disconnected the caps lock key from the character ROM. But then when I was trying to solder J7A, I managed to remove the right hand side of it because it's just a thin trace on the board and it just peeled away. So after I'd broken J7A, I could obviously no longer short it, so I had the idea that I could put a wire between the top left and the bottom left terminals, thinking that would connect the 64128 line at the top to the character ROM output on the bottom left. But of course what I was actually doing was connecting the caps lock key to the 64128 line. So the computer would start up okay until I pushed the caps lock key, when it would completely crash. I couldn't work out why, but of course on retrospect now I know that that's what was going on. Of course it was just shifting vast quantities of the computer into 64 mode, including things like swapping the ROM under the system's nose. So I hurriedly removed that and tried to work out what was going on with my multimeter again. Now also at this point the caps lock key stopped behaving like a caps lock key and wouldn't even change the characters it typed, so I thought I'd completely messed the machine up, and in the process of soldering and unsoldering I also managed to lift the top half of J7B off the motherboard as well. So at this point I thought I'd completely wrecked the machine, so I gave up and went to bed. The next day I had to think about it and thought, if I just put a wire between the top left and the right hand side, that'll connect the 64128 line to the character ROM, and there must be something else going on that affects whether the caps lock key works or not, perhaps a terminal underneath the motherboard or something. So I thought I'd solder that wire and see if it worked, which it did indeed, and everything seemed okay except the caps lock key was broken. But then I had a look and realised that the caps lock key problem was nothing to do with what I was doing. It was entirely caused by a pin on the connector for the keyboard cable just pushing out. So I just pushed that back in and everything started working perfectly.
Okay, so now we've finished all that, let's have a look at how the computer behaves with the modification. Right, so if you saw my previous video, you'll know that the video output on my 128 is a bit screwed up, so sorry about the poor picture. But what we're looking at here is the 128 just after power up, and if I change to lowercase mode you can see that the lowercase I is sans serif, which is the Commodore 128's font. If I press the caps lock key nothing changes, so the font doesn't change, which is good. But if I do press the caps lock key and I type some letters, then they're in uppercase, which is exactly what I want, and lowercase if it's not pressed. Now if I switch to Commodore 64 mode, you can see just when I press Y that the new font is loaded, and the characters on the screen will change to the Commodore 64 font, which will give you the serif version of the I. And there we go, we're in Commodore 64 mode. Switch to lowercase and again you can see that the I is in lowercase. The caps lock key on Commodore 128 mode does absolutely nothing, and you have to use the shift key to get the uppercase. So I think that's all correct for how everything should behave. Okay, so I've also checked 80 column mode and confirmed the font's always the Commodore 128 one, regardless of the position of the caps lock key at power up. So I think this project was a success, even if the work I did to actually do it was a bit shoddy. And it shows you can convert an international Commodore 128 to a UK-US version just by changing the ROMs and adjusting some jumpers. So I hope that was interesting and useful, and see you next time.